Hello everybody, in this video I will talk about denormalization. We know that normalization is the process of breaking bigger table into smaller tables such that update anomalies are removed. When we do normalization of database tables, redundancies or repetition of the records will be removed. And we can easily do edit or update of those records, those tables easily. We don't have to doubt that there will be inconsistency after update in the tables in case of the normalized tables. But in real world situations, we may need data efficiently. We may need data in very short duration of time. In case of the normalized database, there will be different number of tables, means there will be many tables. And we may need information joining those different number of tables. Joining different number of tables to extract information results in inefficiency, because we know that joining process involves Cartesian product and select operation, and Cartesian product is expensive. It is a time consuming process. So how can we generate information of our need efficiently? So in that case, we may have to do denormalization of the table. Denormalization is the process of optimizing read queries. How easily, efficiently we can extract data from the table. That is the basic concept of denormalization. When we think about the denormalization, we do not think about data update, data edit. We just think how we can extract data efficiently, quickly. So we will be generating denormalized table from the normalized tables. Okay, we will be initially predicting, okay, what may be the information requirement of the users in the future. On the basis of that prediction, we will be creating tables, joining different tables. In the denormalized table, we will be having information about different entities. Definitely there will be repetition of the records, no problem, because we are not going to update that table. We just wanted to retrieve information quickly from that table. Here I have created a simple example. Okay, let's see this database. I have created database simple database. Okay, this is the table, different table. This database table shows information about HR department of an organization. This table shows, okay, what are the tasks given to which employees are working in which department. These informations are stored within this normalized tables. We can do update easily within this database schema, no problem, because these tables are normalized. So we don't have to think that update editing of the records will result in inconsistency of the data. These are normalized tables, and these tables may contain innumerous number of records. And when we have to extract information from these tables, it may be time intensive. For example, we need the name of the employees who are working as supervisor in sales department. In that case, we have to join employees table with works in table, then department table. We have to join three different tables, and if there are lots of records within those three tables, then it will be a time consuming process. So what we can do is, we can initially create flat table containing information of the employee, department and work scene. Flat table. Okay, I have written a simple query here. Okay, I will get that query. Here I have written it. Okay, this is the query. Control C, Control V. Now let's execute this. Okay, now this is the table. This table contains information about employee, their post and their department. So from this table we can immediately say who is sales manager, who is HR manager, who are the people working in sales department. We don't have to join different tables. This is a flat table. This is denormalized table. There definitely we can see the redundancy. Okay, but this table results in efficiency when extracting the data. We can immediately know, okay, how many male people are working in account department, or how many female are working in HR department from this single table. So this denormalized table help to answer user's query efficiently. Now let's see one more example from this database. Now suppose we want the name of all employees who are assigned the tasks that is started in particular date and those tasks have been completed. We wanted the name of those employees who have been assigned to the specific tasks started in a specific date and now those tasks have been completed. So in order to answer that query, we have to join employees table with tasks table, then tasks to assign tasks, completed tasks. So we have to use 4 different tables: employees table, tasks assigned to, tasks completed. And if there are lots of records, and definitely this join process will take some time. So what we can do is we can generate flat table. Here is the SQL, Control C. Now let's fire this, Control A, Control V. And let's execute this. Now we can see this flat table is containing information of the employee. It is also storing information of the tasks. You can see here task ID, nature of tasks, start date, end date. These are the information of the tasks, and remark how the task been performed by the employee. That remark is part of the task performed by employee when the task was assigned to employee. So all informations are stored within one single table. That is a flat table. This is an example of denormalization, and from this table we can immediately answer our queries. Okay, who are the employees that are assigned to tasks started in a specific date? Okay, we can see the task start date and when those tasks have been completed. So these flat tables help us to retrieve information need of users immediately. So when we have to do data analysis, initially we will be predicting, okay, what are the information users will be expecting. On the basis of that expectation, we will be generating flat tables, and those flat tables will be used to answer users query. So users will get information of their need requirement immediately. They don't have to wait, because in the background there is a solid flat table. We don't have normalized tables. We don't have to join different number of tables. And joining different number of tables is an expensive process. So remember that when we need to answer users query efficiently, in that case we have to use denormalized tables. And in case of the denormalized tables, we don't have to do any kind of updates. So we don't have to worry that this denormalized table will result in inconsistency of the data. So remember, normalization is needed when we have to do lots of edit within the data. For example, in case of the bank, when the customer does deposit of the money, withdraw of the money, there frequent update will be going on. In that case, definitely normalized tables are required. In the department store, when lots of purchases are made by the users, in that case lots of transaction will be done, lots of transaction will be updated. In that case also we need the normalized tables. But when we have to do data analysis, where we are not going to do any update, in that case those normalized tables results in inefficiency. So in order to increase the efficiency, we'll be creating denormalized table from those existing normalized table. So this is a very simple SQL where we have joined 4 different tables and generate the flat table. So in this way we can generate the denormalized table containing information about different objects, and definitely there will be the repetition of the data, and these denormalized tables are generated to optimize read-only queries. Okay, thank you very much for listening. Thank you very much.